In this video, we're going to look at how to run a quadratic regression model using your graphing calculator, and we're also going to talk about how to field various questions pertaining to the model with the graphing calculator. The example we're going to use is on the screen in front of you here. It's question 26, and the title is Height of a Ball. Now, if you have a graphing calculator handy, it may not be a bad idea if you were to pause the video and key in this data yourself so you can follow along on your own calculator. I would key in the x values into list 1 and the h values into list 2. Now, if you remember in a previous video about fielding quadratic applications, we talked a little bit about things that you're typically asked when you do quadratic regression or quadratic applications. And so there were 3 questions. And we're going to show an example of each of these in this particular video, even though number 2 is not explicitly asked by the text. We'll show you how to do that. So remember again, these questions are often not asked directly. They are often asked in the context of the problem. And so part of the struggle here is you need to read between the lines to see what they're really asking. So let's go back and look at our question, and we'll see what we have here. The question says, height of a ball. A shot putter throws a ball at an inclination of 45 degrees to the horizontal. The following data represent the height of the ball h in feet at the instant it has traveled x feet horizontally. So in other words, they're giving you the height as a function of the distance from the thrower as measured horizontally. And I can't recall seeing a shot putter throw this far, but let's just go with it for the sake of discussion here. So in part A, the question is asking, use a graphing utility to draw a scatter diagram of the data. Comment on the type of relation that may exist between the 2 variables. So what they're really asking for here is, number 1, a scatter plot, and number 2, they're asking what kind of model should we be using? Should it be a linear model? Should it be some other kind? Let's take a look at the calculator. Now, as you can see, I've already got the data keyed in just to save some time in the video here. Again, if you'd like to pause the video now and key this data in, that would be perfectly fine as well. The first thing we're being asked for is a scatter plot. So once you have the data keyed in, you can quit this. And if you recall, you'd go to the stat plot menu, and you need to turn on one of these plots. Doesn't matter which one. I'll just go with plot number 1. Press enter to make it on. And the icon which is flashing right now is the one that we want. That is a scatter plot. So everything else is fine. X list is list 1, Y list is list 2, just like we want. And the mark, in case you hadn't noticed, is a reference to the type of icon that's going to be used on the screen when you actually do the scatter plot. So the individual data values will be represented by a little box. So everything is good here. And if you want to get this up on the screen in the appropriate size window, you can quit this. And you can use zoom 9, which is zoom stat. If you recall, this function automatically sizes the window to accommodate the data set. And so it's good enough to get started with. There's our data set. And as usual, we'd probably want to refine this a little bit, but we'll get to that in a second. Now let's make sure we're answering everything they asked. They asked us to produce a scatter diagram, which we did. We showed you on the screen. And they also asked to comment on the type of relation. Now when you look at the screen, it's clear that you see a sort of a parabolic arc here. And so clearly for what we see, and this is in fact the entire data set, I would say it's very reasonable to use a quadratic model. So in response to the question, there is a quadratic relationship between the data values. Let's see what else they're asking. In part B, it says, use a graphing calculator to find the quadratic function of best fit that models a relation between distance and height. So in other words, they're asking you to run the quadratic regression model, and they want you to use the x values, distance, and the y value should be the height, h. And so how does that go? Well, here's the graphing calculator. You probably want to quit this, and you'd go to the stat menu and the calc submenu. Now the calculator can do several different kinds of regression models. So if you recall linreg, that's linear regression. It can also do quadreg, which is short for quadratic regression. That's the one we want here. Cubic reg would be a 3rd degree polynomial fit to a set of data. 7, quartreg is short for quartic regression. That's a 4th degree polynomial. And then of course there are other models as well. So like we said, we're going to use function number 5, and to get it going, we press 5, and everything looks good here. Now, if you have a more recent model and you have the same operating system that I have, there's a shortcut that you can take here to get the regression model stored where you want it. Let me jump out of here for a second. If you remember, in a previous video, we showed you that we basically want the regression equation to be saved in one of these memory registers here. So usually y sub 1 is the best choice. And you can have the calculator do that directly if you're using the same operating system that I have here as follows. Just quit this. So again, we need to run the model. Frequency list you can ignore. And here under store regeq, you need to put in the name of the memory register where you want that regression equation stored. So you can go to vars, you can go to yvars, you can press 1, and then you can press 1 again, and press enter, and now when you're done, the calculator will automatically store that regression model for you in the y sub 1 memory register. Let's run the model. The command flashed very briefly on the screen there. I will show you that again in a second, but here's our model. And we understand completely that if you're writing this down on a paper or on an exam, something like that, you're going to be writing down a rounded version, just for convenience, right? But it's important to know that when you use the calculator, you want to use the full precision which is available to you, and that means using the unrounded version of the model. That's why we want the calculator to stash it for us in the y sub 1 memory register as we did. And I'll show you how to do that if you're not using the same OS in just a second. But before I do, you should know that with these models in particular, any kind of polynomial regression model, the leading coefficient is very sensitive to round off. So that is the main reason that we want to use the full precision version of the model when we do calculations pertaining to that. Any round off there can cause you to get wildly different values than what my lab is expecting or what you would find on an exam paper. So it's very, very important to know that. Now, as you can see, the model is there. So what if you don't have the same operating system? How do you save it there? Let me show you again. Clear this out here and quit that. And by the way, here's the command that I just ran. The cut and paste interface sort of hides it, but that is the syntax of it. And you may not have this here, the comma y sub 1, and so if you don't, that's not a concern. It would probably look like this, and if you run it again, you can see your model there. So how do you stash that? Well, you go back to the y equals menu. You want y sub 1 lit up. You go to vars, you go to number 5, which is statistics. Use the arrow keys to go to EQ, short for equations. And then number 1 right there is regeq, and that is the memory register which contains the most recent regression equation that the calculator has done. So all you have to do is press 1 and then press enter, and once again you have your regression model saved where you need it. Now if you go back to the graph, you can see that the calculator will superpose the regression model over the data set, and it looks like it's a very good fit. So we have a little bit of a wiggle as we would expect, like that point right there, but by and large, it looks like it fits the model. The model fits the data fairly well. Now, before we commence with answering any questions, we probably want to fine-tune the window size a little bit, just so we can see everything. So right now we're going from 2 to 218. I'd probably go from 0 to 400, let's say. Make the scale 50 or 100 or whatever seems good to you. On the y-axis, I'll go from 0 to 100, and I'll make the scale 10. Again, don't touch XRes or delta X or trace step. There's no reason to. Here's my graph. Everything looks great. And I can see what I would expect to see if I was going to do this type of a model here. I suppose I could tighten up the y-axis a little bit, but it's fine. It'll be okay. Let's see what else they're asking. So we've responded to part A. We've responded to part B. And presumably you've written down some version of the model for part B. How many places of accuracy? 4 or 5 is fine. But make sure you have the model saved in the calculator. Part C says, use the function found in part B to determine how far the ball will travel before it reaches its maximum height. Now, it's sort of natural to read that and to wonder, so do I use the one that I wrote down on my paper, or do I use the precise one that I have in my calculator? Most of the time, the question should stipulate which one. If it doesn't, well, then you kind of go with the flow and see which one seems to work the best, if necessary. But I would always use the one in the calculator first. I mean, that's just natural that you would want full precision. So what are they really asking for here? Use the function found in Part B to determine how far the ball will travel before it reaches its maximum height. Well, if you remember, when you look at quadratic regression, there's some questions that are frequently asked. One of them we mentioned before is plug in a value and evaluate the model there. You can solve for an output value and you can find the vertex. So this particular question here is asking for the x coordinate of the vertex. Part D is asking for the h of x coordinate of the vertex. And we've actually answered part E already because we've already graphed the model superposed over the scatter diagram. So how would we find that vertex? Well, if you're using the full precision of the calculator, you'll do a maximum as we did. So you can quit this. You would go to the second trace menu and you'd use number 4. It's going to ask you, well, where is that at? Now I'm looking at my scale here, and if I recall, this scale was 50 on the x-axis. So that's 50, that's 100, and that's 150. So it looks to me like the vertex is somewhere in the neighborhood of 150. So as far as a left bound is concerned, I am going to go with, let's say, 120. And as far as a right bound, yeah, I'll go with 180, let's say. And as far as a guess, well, I'll put in 160 and see how that works. So the calculator runs, and you can see the answer to part D and, let's see, excuse me, part C and part D on the screen there. So part C, again, is asking for the x coordinate of the vertex, and part D is asking for the h of x coordinate. And so those answers are visible right there. Now the question doesn't seem to say anything about rounding that I can see, and so it's leaving it up to our discretion in that respect. So what would I render for these? Well, I would probably round that to the nearest foot. I think that should be sufficient. If the instructions for the question said otherwise, then I would do otherwise. But in this case, 138.97 would round to 139 feet. If you insist on going to the 10th, you could round it to 130, well, 139 there as well. And then as far as the actual maximum height achieved by the ball, if you round it to the nearest foot, it'd be 77.0. If you round it to the nearest 10th, 77.4. Now again, my lab should give some instructions typically regarding the accuracy they want. They understand that people struggle with this, and so they try to make the questions as specific as possible. Not always the case in the text. So let's go back and see what we have answered for this here. So if you recall, part A was asking for the scatter diagram, which we did on screen. Part B was asking for the model, which you can see is provided here. And in this case, I rendered the model to 4 places for each of the coefficients. Now, part C can be answered a variety of ways, if you recall from previous videos. For example, you can use the vertex formula as shown there, but you notice that if you're going to use that, you're using a rounded version of those coefficients. And so the answer you're going to get, obviously, is going to be suffering from round-off error. So I think that a better answer is the one obtained from the calculator, which would be 138.98 if you're rounding it correctly. Let's go back and look at it here. 979, if you round it 2 places, would be 138.98. So if you want to give the accuracy to 2 places, that would be correct. And then finally, part D, as we said, they're asking for the h of x coordinate. So you can evaluate the model at that number, or as we showed, you can use the calculator. And we got the answer 77.4 if you round to the nearest 10th. Regarding part E was asking for us to superpose the scatter plot over, or superpose the regression model over the scatter plot, which we did. Now, there's one other question that we probably should field here before we run away from this. I promised in a previous video that I'd give you an example of number 2. If you look at the mock exam and if you look at other questions in the text, you can see that this is occasionally asked. It's not asked here, but how would it be asked if it was? Well, they might ask something like the following. They'd say, you know, at what distance or distances from the thrower did the ball achieve a height of 68 feet? Now you can see that 68 feet is not represented here in the table, so you can't use the table to answer that. You'd have to use the model. And if you were doing it by hand, you'd have to use the quadratic formula, which, you know, that could be very tedious. But you can do it very easily using the calculator as follows. What you need is a horizontal line at the specific height that you're after, which in this case is, we said 68 feet. So you go back to the y equals memory register, don't touch your regression model, but put a horizontal line there at 68 feet, and then draw the graph again. And what you're looking for here is the intersection between the red horizontal line and the blue graph of the quadratic model. And so the best way to find that would be as follows. You can go second, trace, and you're using the intersect function, number 5. Now you can see that there are 2 intersections, so each one has to be found separately. So let's say we're looking for this one over here first. Now right now, the calculator is asking, well, what do you want to use for the first curve? Well, I want to use the regression model, so just press enter to affirm that. The second curve would be the horizontal line. Again, press enter to affirm that. And then it's asking, hey, could you get me somewhere in the neighborhood? Yeah, you can give it a value if you want, or you can use the cursor to move around. You can also just press enter and it'll find it. This is a very uncomplicated situation, so the calculator has no difficulty to find it. And so in this case, it's returning the value of 189.21. Now there's another value over here, as you can see, and to find that one, you just put in different boundaries. So again, you go back and you hit second trace, function number 5, intersect, and first curve is indeed the regression model. Second curve is indeed the horizontal line. And to get that first intersection, you probably want to go a little closer to it. So I'm kind of moving over there with a cursor, and then when I press enter, as you can see, it coughs it up. So it's very, very easy to solve that using the calculator, and you can achieve a very high degree of precision. And you can see in both cases we have exactly the y value that we wanted. And we're not using the quadratic formula. Hope that's helpful. If you have any questions, please drop me a line.